Just a reminder, wala ko nag sa for intended for other sections but not proper. In those cases like kung mag TV will appear. So far, the only activity that is available this time is the unit exam, which is for the entry is test. But before you can access the thermocare, I'll just to anyway dito problem sets and in the discussions. So example would include, let's say, this one G and the for hit and two like produced, released, given off, then those kind of heat refers to a process known as exothermic. So mean to say, your value there for the Q is negative. So in similar manner, this example, you have here a fuel that undergoes combustion. So we would anticipate that for any combustion reaction, most of the energy there is lost to the surroundings in the form of heat. So that's why automatically combustion, the other keyword here is produced. So that would be negative. So again, if those are the keywords, then you have negative quantity for heat. So the other one is absorbed. So if you have absorbed, then that is positive. So let's go to work. So again, ang work, you have positive, negative. So it depends on whether the work is performed by the system or whether work is performed by the surroundings to the system. So if it is the system who does the work, then it is negative. So according here, you have a fuel that burns, constant pressure, produces heat, and thus, so it is the fuel itself that is in a combustion process that is performing the work. So therefore, the work here is negative. So kung ano na pag-quantify, then follow the formula. Delta E is equal to Q plus W. Then solve for the change in internal. Then for E per mole unit. So when you have per mole, so you need to divide with the number of moles of the given reactant. More of the lecture on the different parts of the atmosphere as we reach the later part on environmental chemistry, especially air pollution. So we'll be dealing there with the role of ozone layer, the structure of that. Is what happened to the window kasi na-close ako. Wait lang. So the role of your ozone, ito man So you know how to convert from one unit to another unit. Problem is the usual problem we encounter for finding the reaction pressure. So the question asks you how many kilojoules of heat absorbed. One is so the reaction between your magnesium and oxygen, actually it's very, what's this, vigorous reaction into the between like the, that's the magnesium ribbon, and that's being ignited in the candle or burner, so that would be the light that is produced. And oxygen in the air would react with your magnesium, and then of course it will burn, and you produce the white ash. Kanang white ash, kanina makita din niya kana siya, that is your magnesium oxide. So if that is dissolved in water, and you mix that, that is actually a soluble, it will be dissolved, and then we're going to test that with a litmus paper. The red litmus paper would eventually be converted into blue. So the indication is that the mixture there is basic. There's a basic kind of mixture. So that's one reaction for your magnesium oxide formation. But since the question here is requiring the opposite, the decomposition, so we need to reverse the reaction. So when the reaction is reversed, following the rules in thermodynamic equations, if you reverse the reaction, the corresponding sign of your enthalpy will also be reversed. So from negative, you would see here in the solution that it is converted into positive. So in the balance equation, you have 2 MgO. So we also see here 2 MgO. And then the corresponding enthalpy of reaction. So we get here 602 kilojoules. So the number of significant figures, we follow with the least number of significant figures. 3SF, 4SF. Least number. Then the correct, that would only be credited for 2.70. So we need to properly round off the answer and then express that one to the correct number of significant figures. Okay. Two kind of, as long as required reactions compare. And then i-match nimo siya sa unsay given unsay required. So looking at kung dili mo match, we do something, either we reverse, we divide, we multiply. So we can look into calcium oxide. So asang reaction ay calcium oxide? We have asang reaction ang calcium oxide? One or two. Asa? oxide sa reaction 2 but
Divide.
nimo nimo positive then one half. Yes, Eddie.
Na sir, tawag na sir.
Okay. So mo to siya. So ang given nga calcium oxide sa product, ang required nimo sa taas reactant. So we need to reverse. 1 mole hard ang given. So we need to get the reaction reverse po the positive. Reactant ang given, required reactant. So the same. So we just copy. So that's why we have negative 812.2 plus 1 half positive. You get the sum. So station, this was station with the least number of places. So in a figure with this place. 177.9 kilojoules. So the technique in, let's say, enthalpy of reaction nga Hess law is i-match ra gid mo ang given o ang required. So the given reaction, you match that to the required reaction and then you decide whether mag-reverse. One, the usual mass to heat. You have to take note that given quantity, the mass of is the balance chemical equation, the thermochemical equation. So look at G